This problem is typical of the complexity of problems solved by modeling with linear programming. Here, a furniture manufacturer makes wooden tables and chairs. The production process involves two basic types of labor: carpentry and finishing. A table requires 2 hours of carpentry and 1 hour of finishing. A chair requires 3 hours of carpentry and half an hour of finishing. The profit is $35 per table and $20 per chair. The manufacturer's employees can supply a maximum of 96 hours of carpentry work and 20 hours of finishing work per day. How many tables and chairs should be made each day to maximize profit? So here we have tables and we have chairs. We'll let T equal the number of tables, C equal the number of chairs, and there is a default constraint that the number of tables is going to be greater than or equal to 0 and the number of chairs is going to be greater than or equal to 0. So now we move to the carpentry, which will be measured in hours, and the finishing, again measured in hours, and the profit in dollars. And we see that the tables require 2 hours of carpentry, 1 hour of finishing, and provide $35 per table profit. So when we are making T tables, it will be 2 T hours carpentry, 1 T hour finishing for a profit of $35 T. For the chairs, we have the chairs require 3 hours carpentry, 1/2 hour finishing, and have $20 profit. And so for the chairs, we'll have 3 C hours carpentry and 1/2 C hour finishing for a profit of $20 C. We can total these so that we get 2T plus 3C as the number of hours for carpentry, T plus 1/2 C as the number of hours for finishing, and the profit of 35T plus 20C. This is what is called the objective function. It is the function that we are trying to maximize. Now we come back to constraints, since there are some additional constraints here. Carpentry work is limited to 96 hours per day and finishing to 20 hours a day. So we have 4 constraints. The 2 new ones together with the 2 default ones. And so the feasible region is the region with T greater than or equal to 0, C greater than or equal to 0, 2T plus 3C less than or equal to 96, and t plus 1/2 c less than or equal to 20. In order to graph that region, we first of all focus on the two lines, 2t plus 3c equals 96 and t plus 1/2 c equals 20. For each of these, we'll find the two intercepts ct. So when t is equal to 0, 3c equals 96, so c equals 32. When c equals 0, 2t equals 96, so t equals 48. So we'll go down and we'll graph that line on the axes here. The horizontal axis is going to be c, the vertical is going to be t. So we find 48 on the t-axis and 32 on the c-axis, and draw the line through those two intercepts. Now for the other line, when t equals 0, we get half c equals 20, and so c equals 40. And when c equals 0, we get t equals 20. So on the t-axis, I find 20, and on the c-axis, I find 40. And draw that line through those intercepts. So now the region we're interested in is the one that is excuse me, contains the points on or below both of those lines and includes the points on the axes that are adjacent to that region. So it includes the point 0, 0, 0, 20, and this point here, Q, as well as the point 32, 0. So let's find the coordinates of Q by solving the second equation for t. And substituting this value of t into the first equation. So we get 2 times negative 1/2 c plus 20 plus 3c equals 96. Distributing the 2, we get negative 1c plus 40 plus 3c equals 96, which gives us 2c equals 56, which gives us c equals 28. Now we're going to back substitute that value of 28 into the second equation and get that t equals negative 1/2 times 28 plus 20, which is equal to negative 14 plus 20, or 6. So Q has the coordinates 28 and 6. So now we can move to the chart on the bottom right-hand corner here, and I'm going to be evaluating P at 0, 0, at 0, 20, at 28, 6, these are the vertices of the region, and at 32, 0. And going back up, we see that our P, our objective function, was 35t plus 20c. I'm going to write it as 20c plus 35t because my ordered pairs are in the form c comma t. So at 0, 0, there would be no profit at all. At 0, 20, the profit would be $700. At 28, 6, I've computed the profit to be $770, and at 32, 0, the profit would be $640. And so the maximum profit of $770 occurs when 28 chairs and 6 tables are manufactured. So the answer, 28 chairs and 6 tables, maximizes the profit. And that's our answer. Doesn't ask us what the profit is, although it could. It's $770. This is our answer.